We know that atmospheric escape from Mars is a major driver for the evolution of the Martian climate. We know that Mars at least was episodically warm and wet for a couple billion years, but hasn't been so for about 2 billion years or so. And we think atmospheric escape is a major reason for that. And ESCAPADE is going to bring an unprecedented stereo viewpoint because we're going to have two spacecraft at the same time. And that's important because when you only have a single orbiter, you can think of that orbiter as kind of like a weather buoy. You have to be in the place where the conditions need to be monitored. If you only have one spacecraft, you can either measure what the sun is throwing at Mars, the so-called space weather environment upstream of Mars, or you can measure the conditions close to Mars in its upper atmosphere where the atmosphere is escaping. But you can't be in two places at once. But we can, because we have two spacecraft to do this. So we can really get that cause and effect at the same time. We've never had that before, and that's really exciting. And the last reason why it's also very relevant, we think, this kind of science at Mars is because we need to understand the space weather environment at Mars in order to better forecast space weather conditions that can cause hazards for future robotic and human explorers, both in terms of the radiation environment that happens when you get a coronal mass ejection or other interplanetary shocks, or the distortions to radio signals as they pass through the ionosphere of Mars. If we understand the variability of the ionosphere better, we can help future explorers to both communicate and also navigate better on the surface. So we're really excited.
And again, that was Robert Lillis, the principal investigator for the ESCA